Okay, we're on the Chapter 4 practice test, and we're going to go over those, and I'll label them by the number, so hopefully you can just check the ones that you're having problems with. So the first thing I notice here is that there is a negative outside parentheses, so I immediately put my 1 and distribute. So I need to distribute -1 to all of the terms inside, which is going to change all their signs. And then in class, we learned it's easiest if you rewrite this first polynomial and then just line up the like terms underneath as you go along. And then that way you can add and be done with it. So we have negative 6x cubed. So that goes underneath the x cubed term. And we have negative 3xy. Ooh, look at no xy term. So that means it would go right here in between, because this is x to the third, this is x to the second, so x to the first. And y's go last, because we always do everything alphabetically with respect to the letter that comes first. So x comes before y, so x to the third, x to the second, x to the first, no x. And then continuing on, we get positive 7y cubed, which will go underneath its like term here. So now we can add down the line. So this is -1, which we don't need to write the 1. So -1x cubed is -x cubed. This one doesn't have anything to go with it, so it comes down as positive 5x squared y. This one doesn't have anything to go with it, so it stays negative 3xy. And this one is 7 minus 4, which is positive 3y cubed. And this should be a very, very simple one. Most of the students that miss it, it's because they're lazy and they think, oh, I'll remember to subtract. And they don't, especially like when you get to this one and it doesn't have a like term, they forget to distribute the negative. So do it first, then you won't forget. Practice safe math. That's my motto. Okay, let's go ahead and look at number 2. 2, the biggest mistake students do is they distribute the exponent. We cannot distribute exponents unless it's multiplication inside or division. This is neither. So this means expand it. 2x plus 3 squared means 2x plus 3 times 2x plus 3. And then we FOIL. So don't distribute unless this is multiplication or division inside. So this turns into 4x squared outer plus 6x.
Hello, Ms. Nars.
So outer is positive 6x, inner is positive 6x, and last is plus 9. So that leaves us with a final answer, and for some reason we lost our answer blank. 4x squared plus, combine like terms, 12x plus 9. And x to the second, x to the first, no x. Yep, that's correct. Boy, that's a loud bird, isn't it? Okay. So number 3 is just a straight on FOIL problem. You can see it's already 2 terms by 2 terms. We don't have to do any of the expanding or anything at the beginning. So beginning FOILing, we have positive 10x, and remember add exponents, 1 plus 1, 2. So positive 10x squared. Then we have negative 6xy for O of FOIL, outer. And remember, letters always go alphabetical. And positive 35, make sure you write that as xy too. So positive 35xy. And last, negative 21y squared. So we have like terms again here with the O and I. So that leaves us with 10x squared as a leading term. 35 minus 6 is plus 29xy. And then don't forget to add your exponents on that. Negative 21, 1 plus 1, y squared. So negative 21 y squared for our last term. Is it in the correct order? X to the second, X to the first, no X. Remember, when there's two letters, only look at the letter that comes first alphabetically, and that would be your X. So that is indeed in the right order. Next, we have scientific notation. We learned in scientific notation that the decimal place always goes after the first number that's not 0. So here's the first number that's not 0. So this would turn into 1.56. And we learned in class that you always write times 10 for scientific, and then you count from the new decimal to the old. So any number that doesn't have a decimal place, that means it was at the end. So to go from new to old, we do 1, 2, 3, 4, 5 units to the right. And the other thing we learned in class is when it's a big number, which 156,000 is, it's going to have a positive exponent. When it's a tiny, tiny, tiny little number close to 0, that's when it has the negative exponent. So that's how you can kind of check yourself. For the next one, I go to the first number that's not 0. That would be the 5. So I can either write 5 or 5.0. It doesn't matter. Times 10, and I go from the new to the old, which is backwards 3 to get to the old decimal. So that's negative 3, which matches what I said. When the number is tiny, it gets a negative exponent. When it's a large number, it gets a positive exponent. And you could also write this as 5.0 times 10 to the negative 3, just FYI. And you would do it according to what Alex asked, of course. On a paper pencil test, I wouldn't care which way you did it. But on Alex, you have to follow the rules. Okay, so everybody good with that, hopefully. Okay, for number 5, we have an exponent outside parentheses, and this is multiplication. So look at the difference between 2 with addition. I couldn't distribute the 2, and 5, which has multiplication, and I can distribute the exponent because this is negative 3 times x times y times z. So when multiplication is inside, I can distribute the exponent. So I put a little 1 there because every exponent gets multiplied by negative 4. And if you forget that 1, you're probably going to forget to raise negative 3 to the 4th power as well. So anything without an exponent, we put 1. And if you look at the power rule from your notes in 4.1, power rule says when you distribute a power, you multiply. So 3 is negative, so it needs to stay in parentheses. 1 times negative 4 is negative 4. X is negative 4 times negative 4, which is positive 16. Y is 5 times negative 4, which is negative 20. And Z is 2 times negative 4, negative 8. And then the other thing we learned in section 4.1 is that we are never allowed to leave negative exponents. So anytime negative exponents occur, what you should do is circle them. And we learned in 4.1, you make exponents positive by moving them to the other side of the fraction. So if they have a negative sign at the top of the fraction, move them down. If they have a negative sign in the denominator of the fraction, move them up. Notice I didn't circle 16. It's not going anywhere. It already has a positive exponent, so it just stays put. And another thing you need to keep in mind is that when you move a term down or a factor down, it doesn't change the sign of the base. It only changes the sign of the exponent. That's why it's called exponent rules. So don't change the sign of the -3, only the exponent. So x to the 16th remains up at the numerator on the top because it already has a positive exponent. -3 moves down, but it becomes positive. The exponent, not the -3. Y comes down and its exponent becomes positive. And z comes down and its exponent becomes positive. So that's called the negative exponent rule. It was on page 1 of your 4.1 notes. So now all of our exponents are positive. Now we just need to work this out and we'll be done. So x to the 16th isn't going anywhere. This one, let's practice on the calculator, make sure everybody's good with that. So you would just do parentheses, -3, close your parentheses, and caret to the 4th power. So that is 81, y 20, z 8. And there we have it. So that is the first part of 5A's answer. Okay, so it uses the power rule, it uses the negative exponent rule, and I think that's it. For part B, we are first going to do this term. So anything with a negative exponent can be made positive by reciprocating. So the reciprocal 1/6 is 6 over 1. So it's the same property we did here, but these were whole numbers, so we had to put them under 1. That's the reciprocal. The reciprocal of 3 is 1/3. So, but here it's already a fraction. So to make its exponent positive, rather than putting it under 1 like we did here, you flip the base. Okay, and that's really what we did here. We flipped the base, flipped the base, flipped the base, but this is a fraction. So take the reciprocal at 6 over 1, which is 6. That makes the exponent positive. So 6 to the 1st is 6. Plus, this was also on page 1 of your 4.1 notes. The 0 exponent rule says anything to the 0th power is 1. Not 0, 1. And if you don't remember that, just do a random thing on your calculator. Do 3 to the 0th, and it will tell you it's 1. So don't guess. You have a calculator right by your side. Plus, now this one we did in class. We said think of this as 2 times x to the 0th, because that's really what it is. We just don't write the times sign. So this part is 1, as we just showed on the calculator. Anything to the 0th is 1. But the whole thing isn't 1 because it's 2 times 1, which is 2. So this will be 6 plus 1 plus 2, 9. Okay, so you have to be super careful with that. But keep in mind, if it had been this problem, see with the parentheses, then it is 1. Because that's everything to the 0th power. But this, only x is to the 0th power. 2 has its own exponent of 1. So make sure you understand the difference between these, because lots of times I like to put like both of them in the same problem so that you can show me you understand the difference. So this is just 1 because anything to the 0th is 1. This is 2 times 1, which is 2. And we'll start the next problem on the next video.